na mesa comigo está o concelleiro representando o Concello do Consorcio, o concelleiro da Facenda de Fariña, o comisario do programa ConCiencia e, sobre todo, Xuxo Mira, que todos me coñecen, sobre todo, o profesor Max, que debe explicar. Non vamos facer un millón de presentación, voy a estancia do Concello.
Boas noites. En primer lugar, agradecer a Universidade e ao Consorcio a invitación ao Concello para a presentación deste acto. En lugar de escutar a asistencia do alcalde e simplemente dada o que aparentemente eu noto desde aquí o nivel de ciencia que hai nesta sala e desde un modesto economista entre tanto matemático e tanto físico que pode haber por aquí é simplemente animar o consorcio na medida da representación que ten o Concello dentro deste organismo para seguir colaborando en este tipo de jornadas que, en todo caso, para unha universidade da categoría de historia como a de Santiago de Compostela, entendo que é un complemento importantísimo, sobre todo porque hai que reconocer que a presencia de científicos da talla como nos acompaña os edificios de Davis Black, pois sempre poder escutarlo directamente dentro do que é a formación de os estudiantes e do propio profesorado, supoño que é unha axuda para seguir explicando as que traballan. Por seguinte, moitísimas gracias pola invitación e enhoraboa aos compañeros.
Antes de pasar a presentación conferencial, obviamente dita, eu quería darlle a benvida a ella, a todos ustedes, a unha cidade universal, chea de visitantes, pero tamén un país universalizado polos emigrantes e os exiliados. En todo caso, el que coñece o homem do século XX, que coñece precisamente o que se ha trasterrado por súa familia de Hungría e que é de alguna forma unha representación viva do século XX, creo que a súa presencia aquí ten moito significado por a minha parte, por suposto, tamén vamos agradecer a colaboración e recoñecer e poñer de manifesto a colaboración entre o Concello, o Consorcio e a Universidade de Santiago de Compostela, que no espacio de un mes, con alguna intervención de outra entidade tamén, nos vai permitir que pasen por aquí nada menos que 4 premios Nobel ou asimilados. Eu creo que iso é un luxo que nos estamos permitindo e entendo, ademais, que é un luxo que nos podemos permitir. Estamos falando dunha divulgación científica que cargo de líder mundial da ciencia, que va máis alá dunha conferencia e máis alá desta conferencia. Como viu outro día no caso do premio Nobel de Física, todo un conjunto de actividades, de encontros, de comidas, de relacións con xovens investigadores que permiten, me parece a mí, sacar el menor provecho a este tipo de iniciativas. De feito, a vertente divulgativa do programa ConCiencia que fai é intentar chegar á cidadanía a obra de persoas especialmente importantes a nivel mundial no campo do seu traballo, pero en realidade o que tamén fai, o que tamén se consigue é poñer en evidencia e situar a propia vía de desenvolvemento da Universidade de Santiago de Compostela en moitos destes campos. E, por outra parte, como vimos outro día, como vemos hoxe, e como veremos tamén en alguna outra intervención, en realidade, o que temos é un público de científicos que é o que está hoxe facendo e que é o que se pode esperar nunha cidade académica e universitaria como Santiago de Compostela. En todo caso, insisto e agradezo a sensibilidade do Concello e do Consorcio de Santiago neste sentido que me agradece. Dixen antes que o profesor Peter David Dax é un home do século, efectivamente naceu en 1926, e para mí, que non son especialista na materia, ni siquiera próximo ás matemáticas, sin embargo, é todo un personaxe da historia da ciencia, e da historia en sí, con mayúsculas do século XX, do século de extremos, alguén que nace no período de entreguerras, é dicir, antes incluso da chegada do fascismo, dos fascismos ao poder, e moito antes de que se imaginase a Segunda Guerra Mundial. Pero ademais ele vai traballar con von Neumann e de feito se lo vai falar ben. E por lo tanto, de alguma forma, vai facer unha biografía científica, que é algo que desde o punto de vista para mí foi moi querido. E vai traballar cada vez no proxecto Manhattan, e vai traballar cada vez nos dinosaurios, é dicir, en ámbitos que para nós son casi ou casi exclusivamente cinematográficos, para os profanos, quero dicir, non para os especialistas que temos hoxe. En todo caso, sí que é verdade, e isto incluso os profanos só lo sabemos, é un dos matemáticos puros aplicados máis importantes dos nosos tempos, e, digamos, o seu traballo, o seu é coñecido mundialmente, e hoxe aquí tamén, neste acto, nesta conferencia, que esperamos sexa, digamos, de máximo interés, en a que, a posteriori, como río xa, no caso da conferencia previa, confiamos en que haxa intervencións, preguntas e cuestións, seguro que se lle queira plantear ao noso conferenciante. Entón, tamén, gracias.
Estimado señor vicerreitor de Relación Institucionais, señor concelleiro de Facenda Santiago de Compostela, profesor Max, amigos e amigas, o programa ConCiencia ten a ambición de traer a Santiago aos principais líderes mundiais da ciencia. E dende logo a lista, tanto do ano pasado como deste ano, está o conseguindo plenamente. Pero no caso de hoxe, aparte de traer a un dos matemáticos máis importantes da segunda metade do século XX, temos a oportunidade de disfrutar de alguén que foi testemunha directa de feitos de gran relevancia na historia contemporánea mundial desde finais dos anos 30. E é que, en 1941, en plena Segunda Guerra Mundial, unha familia húngara escapaba do horror nazi vía Lisboa cara aos Estados Unidos. Tiñen a sorte de que o cabeza de familia era o médico do cónsul americano en Budapest. Nesa familia estaba un rapaz, un xoven talento e prodigioso da matemática chamado Peter David Lux, que naquela, en 1941, tiña só 15 anos. Aos poucos meses chegaba a súa nova casa americana John von Neumann. John von Neumann era un dos chamados semideuses do Instituto de Estudos Avanzados de Princeton, xunto con Einstein, con Kurt Gödel e con Robert Oppenheimer. Puxo a prueba e quedou fascinado. Nese momento empezou a funcionar o lobby Univ. Aos poucos meses, na primavera de 1942, en unha práctica sesión de té, Euler-2, o matemático máis científico da historia despois de Euler, se representaba o gran Albert Einstein. E dixo antes que estivo sin dar avante 3 días, despois de darle a conta. Ese lobby húngaro tiña realmente moi boa fama. De feito, entre o plantel de físicos que en nos anos integraba o proxecto Manhattan, aquel proxecto encargado de facer a primeira bomba atómica, existía a teoría de que os húngaros eran marcianos, dada a súa produción excepcional de deseños en física e matemática nunha fracción tan pequena de poboación. E a verdade, botando unha ollada, vemos nomes como John von Neumann, Edward Teller, Leo Szilard, Eugene Wigner, Dennis Gabor, e a cultivar ese mito axudou ese mozo daquela, Peter Lux, posto que con só 18 anos integrábase no proxecto Manhattan. Uns meses antes do trío 23, que foi a primeira detonación nuclear da historia, feita por os norteamericanos en Alamogordo, no México, antes de pegar a contra Japón. Pero sobre a vida científica ainda estaba por empezar. Ele fixo rachadas contribucións á teoría e aplicacións de ecuacións diferenciais, parciais e a computación das súas solucións. Ele é, de feito, o fundador da matemática computacional moderna e o introductor de medios informáticos na investigación matemática tan importante, por exemplo, como na predicción do tempo. De referencia son os seus traballos sobre ondas de choque, de aplicacións non só para comprender os efectos de bomba atómica, sino tamén para o deseño de avións. Cando vaiades un avión, fixáramos na súa fuselaxe e nas súas alas, e nese deseño hai un pouco de Peter Lux. Entre 1950 e 1970, Lax estableceu as bases da teoría moderna dos sistemas hiperbólicos non lineais e a súa aplicación á dinámica de fluidos. En 1957, formula a condición de entropía de Lax, criterio que, a partir da solución das ecuacións de conservación, permite seleccionar o estado físico real de sistemas hiperbólicos como ecuación de Abel. E así como se distinguen os choques físicamente admisibles, os chamados choques de Lax, de todos os matemáticamente admisibles. Outra das súas contribucións máis relevantes é o método coñecido como vagas de Lax, que describe os mecanismos de aparición de ondas llanas, subtónicos, e abre posibilidades de integración de ecuacións ata aquela inabordables. Por exemplo, a corte de integrais ou mesmo a ecuación de Schrödinger. O nome de Lax está contemplado con moitos resultados matemáticos e métodos numéricos de gran importancia. O lema de Lax-Milgrom, o teorema de equivalencia de Lax, o esquema de Lax-Friedrichs, o esquema de Lax-Wendroff, a teoría de Lax-Derrida. Pero, oye, que aparte de ser a figura dominante da matemática aplicada no século XX, tamén é unha figura moi importante na matemática pura. Por exemplo, para a historia que dá a conxectura de gas, lanzada por ele no ano 1958, que tardou máis de 4 décadas en construir. Un dos matemáticos máis versátiles da súa xeración non podía quedar sen que coñecemento. Como sabedes, por todos que estades aquí, en matemática non hai premio Nobel. Pero para lanzarlo, viñeron os noruegos e crearon no ano 2003 o premio Abel, creado pola Zorra Noruega, e que ele gañou xa na súa terceira edición. Por suposto, ganou todos os premios de máis categoría no eido da matemática. A marxe de premios, o que máis fascina da súa visita, para min é que nos conte as súas vivencias, o seu mentor John von Neumann e todos aqueles anos, daqueles tempos. Para min, logo, será un privilexio, e vos podedes dicir que estabades aquí oído que nos decían. Professor Lax, it's a pleasure to have you here in Santiago. Today is my birthday, and you were the best gift that I could have. Thank you.
Thank you very much for these kind and exaggerated words, but even more for the invitation to Santiago de Compostela, an important university in Spain and part of the growing mathematical power of Spanish culture. I have already met many young Spanish mathematicians, and tomorrow I'm looking forward to meeting more, and that is the greatest pleasure. I have only one transparency to show, that of von Neumann. I'll leave it up there. It shows him perhaps somewhat rare, the moment of laughing. Von Neumann was the most remarkable person, and even though I will do my best to describe him, it's impossible to appreciate him without actually meeting him, but I'll try. Von Neumann died 15 years ago today, but he looms larger than ever as the most significant scientist of the 20th century. He is one of its greatest mathematicians, one of the fathers of modern computing, the prophet of the age of technology. And my aim is to paint a picture of the fertility, power, and sweep of his mind, and to describe how his ideas shape the future. Neumann was many things, but primarily a mathematician. His genius was in his mathematics. Mathematics, combined with uncommon common sense, pervaded his thinking about everything. Had he lived a longer span of life, died at age 53, he certainly would have been honored by a Nobel Prize in Economics for his work on game theory, and he certainly would have been honored by an Abel Prize, and he certainly would have been honored by a Nobel Prize in computer science. There is no such prize, there will be one of these days. There are many stories about von Neumann which illustrate how von Neumann combined mental quickness, very broad interests, and fearsome technical prowess. Once in a discussion about the rapid growth of mathematics, von Neumann observed that whereas at the turn of the 19th, 20th century, it was possible for a single person to grasp more or less all the mathematics known at that time. Today that is impossible. So someone asked him, what percentage of all mathematics might a person aspire to understand today? So von Neumann went into one of his 10-second thinking trances and said 28%. Another story is about a puzzle which is supposed to differentiate between mathematical and physical thinking, and it's in the form of a puzzle. The puzzle describes two trains 100 miles apart and traveling toward each other at 50 miles per hour. A bird, which is perched on one of the locomotives, starts to fly at the speed of 100 miles an hour, meets the oncoming train, turns around, meets the train, again flies back and forth, and it's eventually crushed between the two trains. The question is, how much distance did the bird cover in its flight back and forth, between the trains? So, a mathematician figures out the answer by noting that the distances between each turning around form a geometric series, and there is a formula for the sum of the geometric series which gives the answer. A physicist notes that since the two trains are separated by 100 miles initially, and each travels at 50 miles an hour, they will crash together in exactly 1 hour. So the bird also flew for exactly 1 hour, and therefore, since it flew with a speed of 100 miles, it will have covered 100 miles. So, according to legend, this problem was presented to von Neumann, who again after 10-second chance said 100 miles. And the person who asked the question said, that's very interesting. That shows that you think like a physicist and you figured out that the bird flew for exactly 1 hour. No, said von Neumann, I summed the series. I once asked von Neumann if this were a true story. He said, not quite. The numbers were so simple. But I would like to start the story from the beginning with the birth of the hero. On on December 28, 1903 in Budapest. He was the oldest of 3 boys in an upper middle class Jewish family. His father, Max, was a banker. Now, you must understand that the end of the 19th century and the beginning of the 20th century were heady times for Budapest. There was energy in the air. Immigrants came in, commerce, industry grew, science, literature, as well as mathematics. There is a good book by John Lukács called Budapest 1900 that describes this situation. Now, at around the time that von Neumann was born, some of the great Hungarian mathematicians and physicists like Leopold Fehér, Frederick and Marcel Ries, George Polya, Gábor Szegő, Alfred Haar, Michael Polanyi, Theodor von Kármán, Leo Szilárd, Havasi, Eugene Wigner, Edward Teller, Gábor, Békesi. They were all born within a 25-year period. The school system was reformed at the end of the 19th century by von Kármán's father, and it was sensitive to unusual talent. And so, Lars Lorenz, the teacher of mathematics in the evangelical gymnasium, recognized the Neumann boys' extraordinary gifts. He informed his parents, but also members of the Hungarian mathematical community, and it was arranged that young von Neumann would receive private instructions. His first tutor was Gábor Szegő, himself a former prodigy and a future very great mathematician. He was professor in Königsberg, then for many years at Stanford. His wife, Mrs. Szegő, liked to recall that her husband came home with tears in his eyes after his first encounter with the young genius. When Szegő left for Germany, he was replaced as tutor by Michael Fekete, another distinguished mathematician who became professor at the Hebrew University in Jerusalem. And von Neumann's first publication in 1922 was with Michael Fekete on the transfinite diameter. Von Neumann was only 19 at that time. Fekete devoted the rest of his career to this subject. Now, child prodigies are not so rare in mathematics. The reason is, partly genetic, unusual way the brain is wired for making logical connections, is that in order to grasp and solve mathematical problems, no understanding is needed of a wider context, which can be acquired only through worldly experience. Now, for most mathematicians, this has the unfortunate consequence that they shy away from problems posed in a non-mathematical setting. This was not so for Neumann. Very few have embraced real world problems so wholeheartedly as he did. After von Neumann finished the gymnasium, his father decided mathematics was of impractical career. Chemical engineering was much more promising. So, young von Neumann went off, first to Berlin and 2 years later to Zurich. But he also enrolled at the University of Budapest for a PhD in mathematics, mostly earned in absentia. In Berlin, Von Neumann prepared for the entrance examination to the Federal Institute of Technology in Zurich, which he passed his outstanding result. 20 years earlier, young Einstein flunked that examination. During the same period, he began to write his mathematical dissertation on a technical sounding but philosophically deep subject: the introduction of transfinite ordinals, which was eventually published under the title An Axiomatization of Set Theory. His purpose was to resolve a slowly brewing crisis in mathematics. And this is how Neumann himself described that crisis. In the late 19th and early 20th centuries, a new branch of abstract mathematics, your Cantor's theorem of sets, led into difficulties. That is, certain reasonings led to contradictions. And while these reasonings were not the central useful part of the theory, and were always easy to spot by certain formal criteria, it was nevertheless not clear why they should be less legitimate than the successful parts of the theory. This crisis split the mathematical community into two camps: the intuitionists, led by L.E.J. Brouwer, would severely circumscribe the way infinite sets are handled, and on the other side, the formalists who believe that proper axiomatization in the spirit of Euclid would free us to handle infinite sets to our heart's content, and at the same time deliver us from contradictions. The leader of the formalists was David Hilbert in Göttingen. The controversy between the two schools was sometimes extremely bitter, I say comically bitter. In 1923, von Neumann went to Zurich to begin his studies of chemical engineering. He made a deep impression on George Polya and Hermann Weil, who were professors there. In 1926, he received his degree in Zurich, and shortly afterwards, he received his degree in mathematics from Budapest. He was not yet 23 years old. Von Neumann's work on the axiomatization of set theory attracted the attention of Hilbert, and the growing reputation of von Neumann earned him a grant from the Rockefeller Foundation to spend a year in Göttingen. When he arrived there, he found that the burning issue of the day was not the foundations of set theory, but the foundations of quantum mechanics. So he set himself the task to put these foundations, the theories of Heisenberg and Schrödinger, on solid foundation. He introduced the notion of an abstract Hilbert space, notion of an unbounded self-conjoint operator, and its spectrum, which was not only basic for describing precisely mathematical quantum mechanics, but became one of the building blocks of mathematical analysis altogether. Furthermore, this was typical of von Neumann. He not only laid the foundations, but showed how they could be applied to concrete physical problems. My teacher, Kurt Friedrichs, related an amusing incident bearing on this. In the 1960s, while traveling in Germany, he met Heisenberg, and he couldn't resist the opportunity to express the gratitude of all mathematicians to Heisenberg for having created a theory that gave rise to so much wonderful mathematics. Heisenberg agreed that this was so. Friedrichs had added that to some extent mathematics has repaid this debt. Heisenberg was non-committal, so Friedrich said, after all, it was a mathematician, von Neumann, who clarified the difference between an operator that's self-adjoint and one that is merely symmetric. What's the difference, said Heisenberg? Now, of course, Heisenberg was wrong, and Neumann was right. By this time, von Neumann's reputation was soaring. He was appointed Privatdozent in Berlin and in Hamburg, and he was invited all over Europe to lecture. But by the end of the 20s, his eyes were on America. Partly because there were so few jobs available in Europe, but even more so because he profoundly feared the instability in Europe. He saw disaster coming before most other people did. So when an invitation from Princeton came in 1929 to come there and lecture on the new quantum mechanics, he accepted with alacrity, and for the next 4 years divided his time evenly between Princeton and Germany. A scientifically important event for von Neumann in these years was Gödel's discovery that every sufficiently rich axiomatic system always contains undecidable proposition. Von Neumann saw that this bloomed the Hilbert program, and it ended his love affair with logic and the axiomatization of set theory. Yet, his efforts were not in vain because they served him well later on in thinking about the logic of computers. This 50-50 arrangement between Princeton and Germany came to an abrupt end in 1933. For two reasons: the rise to power in Germany of the Hitler gang, and von Neumann's appointment as professor at the newly created Institute for Advanced Study at Princeton. Two of his fellow professors were Albert Einstein and Hermann Weyl. The great audition for Gödel was later. The mid-30s were a fertile period for von Neumann. In collaboration with Francis Murray, he made one of his most enduring discoveries in pure mathematics, the theory of rings of operators, to be called in his honor von Neumann algebras. Another of his great discoveries was the mean ergodic theorem, originating in statistical mechanics, but becoming a very important result in a very broad area of analysis. At the same time, the growing political crisis in Europe convinced him that war was inevitable and that it would come soon. He also saw that it would lead to the destruction of the Jews in Europe, much as the Armenians in the Ottoman Empire were massacred during the First World War. You see, von Neumann was a student of history. He knew a tremendous amount of history, and he knew how to apply it to new future events. So it's not surprising, therefore, that he thought of ways of using his mathematical talent to help America prepare for war. At that time, the most mathematical part of warfare was ballistics. And the Aberdeen Proving Ground was not far from Princeton, and he threw himself energetically into the study of explosions and shock waves. In the process, he almost became a first lieutenant in the American Army, but happily he was just over the statutory age of 35. And so, instead of being restricted by the army, he could roam freely over a whole range of projects as a member of a number of committees. And soon his fame as a practical applied mathematician began to spread, just as his fame as a pure mathematician had 15 years before. By far the most important enterprise in which von Neumann had a leading role was the Manhattan Project, the building of the atomic bomb. When he arrived at Los Alamos in 1943, the challenging problem was how to assemble a plutonium bomb sufficiently rapidly to prevent premature detonation. Something the North Koreans haven't quite solved. Von Neumann's knowledge of high explosives steered him to a way to accomplish this. This very great contribution and other great contributions soon established him his reputation as the ideal person to consult if you had any problem in physics or engineering. The brightest stars at Los Alamos, Oppenheimer, Hans Bethe, Richard Feynman, Edward Teller, admired and recognized von Neumann's very great talent. Hans Bethe said, only half in jest, that von Neumann's brain was a mutation upward of the human brain. Nuclear weapons cannot be designed by trial and error. Each proposed design has to be tested theoretically by solving the mathematical equations that describe the physical processes that take place. And von Neumann came very early on to the conclusion that analytical methods were inadequate for solving the problems involved in the continued equations of physical mechanics, and that the only way to deal with them was to take these differential equations, discretize them, and then solve the resulting finite system of equations numerically. The tools needed to carry out such calculations are high-speed programmable electronic calculator, large capacity storage devices, programming languages, stable ways of discretizing differential equations, and a large variety of algorithms for solving rapidly the resulting discrete equations. And von Neumann devoted a large part of his energies after the war to constructing these tools. Being von Neumann, he was keenly aware that the computational methodology is crucial not only for designing nuclear weapons, but also for solving an enormous variety of complex problems in science and engineering. But he went further than that. He also realized that computing can do more than grind out by brute force answers to concrete problems. In a talk delivered in Montreal in 1945, he had this to say. And again, I will read his exact, somewhat elaborate, but always grammatical words. We could, of course, continue to mention still other examples to justify our contention that many branches of both pure and applied mathematics are in great need of computing instruments to break the present stalemate created by the failure of purely analytical methods of nonlinear problems. Instead, we conclude by remarking that really efficient high-speed computing devices made in the field of nonlinear partial differential equations, as well as in many other fields which are now difficult or entirely denied of access, provide us with those heuristic hints which are needed in all parts of mathematics for genuine progress. In the specific case of fluid dynamics, these hints have not been forthcoming in the last 2 generations from the pure intuition of mathematicians, although a great deal of first-class mathematical effort has been expended in attempts to break the deadlock in that field. To the extent to which such hints arose at all, and that was much less than one might desire, they originated in a type of physical experimentation, which is really complicated. We can now make computing so much more efficient, fast, and flexible that it should be possible to use the new computers to supply the needed heuristic hints. This should ultimately lead to important analytical advances. These were prophetic words uttered in 1945, and computers were merely a figment in von Neumann's imagination. But things turned out as he predicted. After the Second World War, von Neumann took on many official duties, time-consuming and bearing a heavy burden of responsibility. For instance, in the 50s, he was one of 5 atomic energy commissioners. He accepted these assignments not only out of a sense of obligation, but also out of a deep desire to leave his mark on the world, and not only on the world of mathematics. The following story illustrates the all-important influence of von Neumann. In the 1970s, Eugene Wigner, great physicist and childhood friend of von Neumann, visited Budapest. And although this was the height of the communist regime, he received a celebrity treatment, including 2 long interviews on television. And he was asked if it were true that in the 40s and 50s, the scientific policy of the United States government was set by von Neumann. Wigner replied with his characteristic precision. That is not quite so. But after von Neumann has analyzed the problem, it was clear what had to be done. In a prophetic article that appeared in 1955 in Fortune magazine, and which is still very worth reading today, under the title, Can We Survive Technology? Von Neumann discusses the danger of modern technology, present and future. He points out that the dangers are not due to accidents and human errors, but they are inherent in the relation of technology to geography and political organization. The increased speed of technological processes enlarges the size, political, organizational, geographical, economic, cultural, of units affected by technology, and this size will become global. Von Neumann was very concerned that the political organization of the world is not ready to accommodate global economic organization. In this article, von Neumann discusses in detail some of the burning issues of today: nuclear energy, automation, communication, climate change. He points out that in modern times, the burning of coal and oil has raised the average of atmospheric temperature by 1 degree Fahrenheit. he points out that sometimes the opposite happens, that the dust thrown into the upper atmosphere by the explosion of the volcano Krakatoa in 1883 has temporarily cooled the whole atmosphere, and had the dust thrown into the atmosphere remained for 15 years, blocking the sunlight, it would have lowered the atmospheric temperature by 6 degrees Fahrenheit. Von Neumann believed that the atmosphere could be controlled. People today think he was wrong in that. But it is very interesting that he thought of it. And also, he was the first to initiate the calculation of weather and climate numerically. The calculations carried out by him and his associates were crude by today's standards, yet they produced results that, by and large, agreed with atmospheric patterns. In this article, von Neumann points out that technological development, even those which are intrinsically useful, can lead to destruction, and that there is no way to separate dangerous technologies from useful ones. They are the opposite sides of the same coin, and therein lies the danger to mankind. Von Neumann asked, and again I will repeat his words, can we produce the required adjustment with the necessary speed? The most hopeful answer is that the human species has been subjected to similar tests before and seem to have a congenital ability to come through after varying amounts of trouble. Here again was von Neumann's deep knowledge of history speaking. He goes on to say, to ask in advance for a complete recipe would be unreasonable. We can specify only the human qualities required: flexibility, patience, intelligence. It is hard to believe that von Neumann's great versatility in mathematics had led some pure and puritanical mathematicians to charge that von Neumann merely skimmed the cream off a subject and left to others the arduous task of getting to the bottom. The following stories only a slight exaggeration. When the mathematics faculty of the Institute for Advanced Study was discussing the appointment of a brilliant young man, the great contributions of this man were described function theory, calculus of variations, minimal surfaces, algebraic number theory. Everyone was wildly enthusiastic about him, except André Weil said, this fellow dabbles in this, he dabbles in that, he will end up like von Neumann. Another group of purists regretted that von Neumann wasted his time on the applications of mathematics. Von Neumann had a project at the Institute for Advanced Study to design and build a computer, which was very successful, but it was very unpopular with most of his colleagues on the mathematics faculty. When von Neumann died, the project was immediately terminated. Von Neumann, in his political opinion, was very liberal. For instance, in the 50s, which were the McCarthy hysterical anti-communist times, he branded as pernicious a suggestion that clearance be required for unclassified research. He said that the training of talented people in science should be done with absolutely no consideration for anything other than scientific ability. Nevertheless, von Neumann was criticized for his politics. Some called him fanatical anti-communist and a cold warrior. This is very unfair. Von Neumann opposed and feared tyranny, both Hitler's and Stalin's. And he saw clearly the aggressive stance of the Soviet Union, and he did everything he could to prepare the United States to resist that aggression. Let me conclude by asking if von Neumann were to awaken today, what would he find most astonishing? The tremendous power, low cost, small size, and ubiquity of personal computers, the internet, advances in computer science and computational science, the genome, the landing on the moon, the collapse of the Soviet Union, global warming, or that the world has not yet grown itself up. The tragedy of von Neumann's early death robbed mathematics and the sciences of a natural leader and development spokesman, and deprived the younger generation from beholding the most scintillating intellect of the 20th century. Thank you.
Thank you very much, Professor Lars. I have to say that the translation was fine. It is the first time during this program of conference that I have been leading the translation. Con respecto a isto, tengo que decirle al traductor que no hubo traballo. Ele contaba que puso por la tarde na roda de prensa, porque claro, que un pouco de traductor. Unha anécdota que sempre conta cando está con traductores, que o seu pai era un amigo do gran músico Belabartok. Belabartok, ao igual que a súa familia, escapou aos Estados Unidos os 14 anos antes de chegar a Hungría. E un día, o pai de Peter Lars trouxe a presencia de Bartok, trouxe un rapaz, un xove músico, de nome Yehudi Minur. Entón, ese rapaz tiña moitas ganas de tocar diante de Bartok, entón, os poñen ali a tocar, e de un cacho, pues, Bartok non se cara serio, e dille en húngaro ao pai de Peter Lars que o rapaz serio que facía. Entón vai, pues, o pai de Peter Lars dille, mira, pues, que me gustou moito, que sabe que comprende esa música, metía así un pouco de rollo, e al final, pues, foi de Bartok ao pai de Peter Lars e dixo, mira, que eu non che farei tanto, que falaches moito. Ele comprende que hai que falar as cousas e logo hai que maxur que a translation was okay. Gracias. Dende logo tamén moitas grazas ao Centro Galego de Arte Contemporánea por proporcionarnos este fantástico marco para esta conferencia. Como non, reitero o meu agradecemento ao Consorcio de Santiago, ao señor vicereitor de Relacións Institucionais, que ademais sendo tamén catedrático de Historia Contemporánea, estou seguro que disfrutou bastante do acto. Xa vim tomar notas no acto da semana pasada con Fran Viche, ao máis que sobre todo hoxe, supoño que tivo moito máis notas. E, bueno, lembrarvos, antes de que se me esqueza, que o programa ConCiencia sigue, o vindeiro acto será coa chegada de John Nash, que chegará na semana do 19 de novembro. O seu acto público será o mércoles 21 de novembro, todo mércoles, na Conferencia de Galicia. E, Bueno, ainda que vai falar de teoría de xogos, o profesor Lax coñécelo, de moitas historias previas. Ele dicía que na comida que John Nash ten moitas máis cousas a parte da teoría de xogos, cousas moi bonitas, e incluso superiores en tamaño. Eu non sei se o director se procede mellor algún tipo de rolda de preguntas, se queren algo preguntar.
Sí, porque ademais, aquí hai matemáticos puros aplicados, matemáticos, historiadores, demógrafos, matemáticos, economistas, pero que o campo está aberto. Porque tamén hai matemáticos historiadores, todo non son extra. Eu creo que sí que procedería a unha cuestión si hai interés para ela.
Sí, eu ia formular. Hola. Miro, mire, vostede antes falou sobre a polémica que houve entre intuicionistas máis outra corrente. Entón, que é para un matemático a intuición? Non cree que iso está, o sea, non encaixa dentro da disciplina matemática, é dicir, é unha cousa estrictamente non científica. Bueno, por outra parte, vamos, sobre o que dixo de Neumann, bueno, pareceme, bueno, demasiado laboratorio, demasiado apologético, no sentido de que non ten, vamos, parece ser que non tiña ningún defecto. E a mí parece que a súa contribución ao esforzo bélico non é precisamente nada loable, non? E que, bueno, que contribui ao desenvolvemento do criminal sistema capitalista que nos está levando a morte do planeta. Entón, vamos, isto a mí me parece que non é nada de todo. Gracias.
You have raised 2 points that we answered both of them. The word intuitionism, it refers to intuition, but intuitionism was a very technical philosophical system, and it would have been very restrictive on the use of mathematical arguments, especially the use of infinity. I think they chose the name intuitionism because intuition is so important in mathematics, but the name and what theory is are not the same things. Let me try to answer you about von Neumann's contribution to warfare. The United States was fighting the Hitler gang, and certainly to contribute to that was the highest virtue, not a crime. Von Neumann was very much aware of the danger to the world of these developments. He didn't live long enough to do anything about it, like his colleague Leo Szilard. But von Neumann was not a warmonger. As I said in my talk, he hated and feared tyranny. And he hated and feared the tyranny of Hitler and equally the tyranny of Stalin.
É uma variante para mim do fascismo. É o fascismo.
Neumann se morrerá en mucho orgullo. Non sei se hai alguma pregunta máis. Sí.
I wanted to know who is your favorite mathematician in history, if you have any.
Could you say it again?
No, que pregúntalle que cal é o seu matemático favorito na historia, se ten algún.
Without doubt, Newton.
What is our prognosis from the physicists? Bueno, curioso porque, claro, pues en una roda de prensa también me preguntaban bueno, que posiblemente os problemas da transmisión da matemática pues, non sino secundario e que os rapaces non teñen pues, figuras tan visibles na matemática como teñen na física, por exemplo. Os rapazos teñen a Newton, que é unha figura moi importante da física, e claro, é unha figura moi importante da matemática. Pois, bueno, os esteticistas tamén. Bueno, creo que estamos a... non sei se o señor director quere dicir unha palabra, a non sei se está unha palabra máis... Creo que o que
Se hai alguma palabra máis. Que parece que non... Sí. Sempre. Cambia a versión.
Yes, it's just to follow on from the previous question. I knew in Oxford slightly a professor who was working on carbon lattices, a physicist, and he realized that his work would help in the development of more efficient nuclear weapons. So, in fact, he stopped his research for those reasons. But he didn't wish to contribute to any more development of these terrible weapons. Now, did von Neumann ever have that sort of thought himself, or moral struggle? Von Neumann died too early for these issues. I'm sure he has thought about the tremendous danger of the proliferation of atomic weapons, but he died too soon to have developed a form of thinking about it. And I don't know if there is anything left in writing. He died, as I said, he died too soon to be able to say what he would have thought about it. In this article on Can We Survive Technology, there is the unspoken danger of nuclear weapons. He does not explicitly discuss them, but certainly he was aware of the tremendous danger to the world of technology. Sorry, if I could just expand, you did say that he was concerned that the economic developments that would proceed over decades, the increase of technology, the growing size of the global economy, did not match with the political structures. What sort of response did this article produce? That's a very good question. I don't know. It would be a good idea to republish this article today and have comments from the point review the 50 years that have taken place since then.
Ben, si non hai máis... sí, hai, sí, sí.
Estoy viendo que el turno de preguntas se está aplicando mucho desde el punto de vista de, está aplicándose mucho en el tema de la influencia de John Neumann en el desarrollo de la evolución de la sociedad y de la parte de la humanidad en este siglo pasado. Se está juzgando tanto la visión de John Neumann como la propia evolución que él más o menos parece que ha dicho acertadamente en varios aspectos, que ha contribuido también en algunos. Yo creo que la evolución de toda la sociedad es un tema tan complicado que no creo que nadie pueda figurarse todos los aspectos y todas las consideraciones que pueden entrar en este tema y que está lejos de cualquier simplemente humana hacer un programa enorme que si funciona no tenga efectos. Por lo tanto, creo que el pobre John Neumann se le han criticado por cómo han ido las cosas. Pues bueno, bastante ha hecho como predecir las críticas así por lo general que están. Yo tampoco tengo nada por decir. No sé, quería hacer este comentario, no sé si tiene algún problema.
No hay problema.
Pero además, aprovechando que hay aquí a presencia de tanto profesor de niveles distintos, había una frase que dijo el señor Lars en torno a la necesidad que recomendaba John Neumann sobre la importancia de estar conectados los matemáticos con la realidad. Ahora, en tiempo de tanta reforma académica, y siempre veo que persoeiros do Univ, do señor Lars, aproveitando que pasan por Galicia, nos dará unha recomendación no senso, desde o seu punto de vista, no seguimento que vai a facer das cuestións dos programas educativos, tanto de base como universitarios, de cara a entender a importancia, e iso digo tal como penso, da importancia que pode ter as matemáticas no desenvolvemento estructural da persoa para comprender moitísimas máis cousas e a veces nos movemos na disputa de horarios, saca de aquí, te pon de anar. Entonces, a mí me gustaría, dentro de esa importante recomendación de que los matemáticos deberían de estar en contacto con la realidad, o que eu entendo que pode querer decir que os matemáticos poden facer moitísimas máis cousas que facer matemáticas en beneficio da sociedade, cal sería a recomendación que daría o señor Lars dentro do que é a estrutura o programa educativo de un país que queira, incluso como decía John Neumann, potenciar evidentemente a innovación tecnológica de cara a poder obter resultados analíticos necesarios para non entrar na necesidade de facer experimentos máis alá do que permite un laboratorio. É dicir, iso é unha máxima que estamos vendo como a necesidade de invertir innovación, pero en realidad hai que poñer as cousas no seu sitio. Entonces, me gustaría saber cuál é a opinión do señor Lars en torno á importancia da dedicación das matemáticas no proceso educativo e a verdadeira aposta pola innovación tecnolóxica para conseguir desenvolver os métodos que sobran analíticamente non se poden hacer.
asked a very big question, and I can give smaller answers. One thing is to improve the teaching of mathematics in the schools. As I mentioned earlier today, if you ask a mathematician what started him off in mathematics, in very many cases, they will say a brilliant teacher. And the trouble is we don't have enough brilliant teachers. We don't even have enough competent teachers. We must improve the education of teachers in schools. Now, I don't know how teacher training is organized in Spain. Tomorrow I hope to learn a little more about it. In the United States, there are so-called teachers' colleges, which are separate from the universities, and teachers learn about teaching methods and psychology of teaching, all of which is very important. It does not replace knowing the subject. And so that is certainly what ConCiencia has to be done. Now, there are today many outstanding young Spanish mathematicians. That is a very happy fact, and it shows that Spain is well on its way to make mathematics, make the power of mathematics count. Now, I don't know too much about interest in applied mathematics, although I believe that there is a lot of interest in that. So, it's important to build up strong schools of applied mathematics.
Bem, sí, no más. No más.
Profesor Max, me gustaría hacerle una pregunta que me diera su opinión sobre esta cuestión. Verá, de un descubrimiento perteneciente a la rama de las ciencias puras, del cual pudiera en ese instante del tipo al momento, al poco tiempo de realizar el descubrimiento, aprender sus implicaciones nefastas para la sociedad, teniendo en cuenta que pudiera las positivas, pero que en ese momento primaran las malas, ¿usted consideraría que, pese a todo, ese conocimiento puro debería revelarse?
There is no way of hiding scientific knowledge. You can hide it for a few years, but that is all. And as von Neumann pointed out, the benefits and the dangers are very often just the two sides of the same coin. So it's a dream that one can leave dangerous scientific discoveries, one can hide them. It's not possible.